Okay, so welcome back, and now we're going to graph this limacon. Now, if we look at this, notice that it's not a cardioid because the A and B are not the same, but notice that A is greater than B, but less than 6, right? Less than twice B. So this is going to be a dimpled limacon, okay? Now, so let's look at this. Okay, so first of all, let's test for symmetry. So again, I'm going to test for, again, with respect to the y-axis, or theta equal to pi over 2. So I'm going to replace both of these with negative values. So we're going to get negative r equals 4 minus 3 sine of negative theta. Now, because this is an odd function, we're going to get the opposite of sine theta. So that means this is going to turn to a plus. So I'm going to negative r equals 4 plus 3 sine theta. Now that does not get me back to the original equation. In fact, if I multiply through by negative 1, I get r equals that. So that still doesn't get me, right? So it fails the first one. Okay, let's do the next one. Let's just replace this with negative theta. So r equals 4 minus 3 sine, and some of you already know where this is heading. So this is going to be 4, and again, this is going to be the opposite of sine, so this is going to make this plus 3 sine theta, and that still does not get us back to the original equation. So it fails that one. Okay, so let's do the third one. We haven't done the third one yet, so let's do the third one. In fact, this is the first time I've done the third one in the videos so far. So that means we're going to replace r with negative r and theta with theta. So this is going to be negative r equals 4 minus 3 sine theta. And so now I multiply everything by negative 1, and I get r equals negative 4 plus sine theta. Nope, does not give me. So it failed all 3 tests. But here's the thing. We know that this has symmetry with respect to theta equal to pi over 2, right? Because of the characteristics of the limacon. Okay, so we know that because this is sine, it's symmetric about the y-axis, or the theta equal to pi over 2. We know that. So even though it failed all 3 tests, we know that it's symmetric. We just can't use symmetry to help us. Well, we can when we plot the points, but you'll see what I mean. So again, so we're going to skip the symmetry. So there's we failed all the tests. So now zeros. Okay, so when is r 0? So here we go. So I'm going to, again, set this equal to 0. So 4 minus 3 sine theta equal to 0, which means sine of theta is equal to what? It's going to be 4/3, right? So if I subtract 4 from both sides, I get negative 4. Divided by negative 3 gives me a positive 4/3. Okay, so now, sine of theta is equal to 4 over 3, which is opposite over hypotenuse. Which is impossible, right? Because this is bigger than 1, right? And the range of sine cannot be bigger than 1. So this thing does not go to 0. Okay, so the radius is never 0 here. Which again, if we're thinking about limacons, it makes sense. Okay, so what's next? Well, what about the maximum values? see here. Let's find the maximum value. Okay, so again, so maximum value, let's do that one next. So maximum value of R. Well, again, the maximum value of R will happen when this is the large, or excuse me, in this case, we're subtracting off 3 times this. So R is going to be the biggest when this is the smallest, because we'll be subtracting off the smallest value. So when is this the smallest? When it's 0. So when is sine of theta 0? When theta is 0 or any multiple, adding any multiple of pi, or subtracting any multiple of pi. So it's going to happen at 0 plus or minus pi times k, which is where k is an integer. So again, so at 0, right? So again, so at 0, this is going to be 0, which means the maximum value is 4. So at 0 degrees, it's going to be at 4. So we got that point, okay? Okay, so now, well, that's the only point we have so far. Oh, let's do pi over 2. Right, it's sine. So let's see where it intersects at pi over 2. Well, at pi over 2, this is going to be 1. Which means this R is going to be 1. And so at pi over 2, this is going to be at 1. And what about pi? Well, pi at 0. Which means it's going to be 1. But it's going to be 1 in this direction, right? So it's going to be at pi, it's going to be at, or hold on. 4, I'm sorry, it's going to be at 4. So it's going to be out here at -4, right? Because remember, it's 180 degrees in positive radius. So it's going to be facing out this way. Okay, so again, just keep in mind this is polar coordinates. Okay? So now, and that makes sense because we're symmetric with respect to this axis. So that makes sense. Now, what about 3 pi over 2? Okay, well, 3 pi over 2 sine is -1. Sine is -1, which means this is going to be positive 3, which means R is 7. So guess what? So again, at 3 pi over 2, you're at 270 degrees, and you're still in the positive 7. So you're going in that direction. So guess what? Your other point is here. Now look at that. Now knowing what I know about Limacons, that's a lot of information that we have. But let's fill in a table. Let's fill in the table. Okay, and let's put in, well, let's see what they do. So they're putting in all of the values except for pi over 4. So they're all doing 30-degree multiples of 30-degree angles and multiples of 60-degree angles, all the way to 2 pi. All right, so let's do this. Okay, so we've got this. Okay, so we got 0, and then we got pi over 6, pi over 3. Pi over 2. Okay, and then we've got theta and r, and so then we've got 2 pi over 3, and then 5 pi over 6, and then we have pi, and then we have 7 pi over 6, pi over 3, um, 3 pi over 2, hold on a second. Yeah, 5 pi over 3, and then 11 pi over 6, and then finally the last one, 2 pi. Okay, so let's put in the values that we know. So we know it's going to be 4 and negative 4, right? So we're dealing with sine. So here at 0, it's 4. And at pi over 2, it's 1. And we know at pi, it's negative 4. Or 4, rather. Where is it? Pi is 4. And then at 3 pi over 2, it is 7. Okay, now let's fill in the rest. So pi over 6, so sine of 30 degrees is 1/2. So this is going to be 4 minus 3/2, which is 1.5. So that's going to be 2.5. So that's going to be 2.5. Okay, good. And then at 60 degrees, this is going to be the square root of 3 over 2. Right? So square root of 3, so this is going to be 4 minus 3 times the square root of 3 over 2. Okay? And then at 2 pi over 3, right? So 2 pi over 3 is going to be, again, 60 degrees, but it's positive, so we're going to get the same thing. So we're going to get 4 minus 3 square root 3 over 2. So it's going up a little bit, right? And then this is going to be 2.5. And again, it makes sense because it's symmetric about the theta equal pi over 2, so the y-axis, so it's doing this and it's doing this, so it's, okay? And so if we fill this stuff in, so let's see, what do I get so far? So 4, 2.5, okay, so this will be 1.4. So if we calculate this, this will be about 1.4. This is going to be about 1.4. And then 7 pi over 6. We get 5.5. And then 6.6. And then 7. And then 5 pi over 3. It starts to go down. So again, because of symmetry. So it goes up to 7, then it comes down. So this is going to be 6.6, 5.5. And then of course, we're right back to 4. Full revolution. So what does this mean? It's going to do something like this. So again, my drawing's not the best. But again, if you did this on a graphing calculator, it would look a lot better. Okay? So again, this is the way we do it when we're trying to sketch the graph of a limacon. And so notice that I had the 1, 2, 3, 4 points, and really once you have the 4 points, you can visualize what this thing is going to look like. And the fact that it's a dimpled limacon tells us, hey, it's going to have this dimple in here, and it's going to have a circular shape, and except it's like a circle with one side dimpled in. Okay, have a great day.